Coming. Waiting.
Hey, incoming. Hey, look at Melissa's already there.
Wow, we've got 10 people in. So
Awesome.
this is a really good idea, just having it done early.
So welcome aboard. Let me do the big reveal. You ready? I'm gonna get rid of the image.
I'm
Bop.
ready.
Welcome, guys. I tried something new today with the logo, so hopefully y'all got to see it. That was my
Wow, we've got 10 people in.
that was my
So this is a really good
Oh
idea,
God!
just having
I
it
gotta
done
stop
early.
this. Hold
Mute
on.
me!
So welcome aboard. Let me do the big reveal. You ready?
Dang
I'm gonna
it.
get rid of the image.
I'm
Bop.
ready.
Oh my God. Welcome, guys. See, I can't do this. I am the worst. I tried something.
So many
I am
knobs
the
and
worst.
buttons.
Okay, I got rid of it.
All right.
Just keeping to our unpluggedness. That's all.
I try to do something fancy and I just fail all the time. Sorry. Anyway, we're here. We're gonna talk about things and current events and solar synoptic maps, which is a word I can't pronounce.
Try saying that 3 times fast.
I can't. I can't even pronounce it normally. But we do have some interesting events to talk about. One is we're in a current, well, we're exiting a high-speed stream. So this is the thing that's been going on the past couple days. And it looks like we had a CME that hit us. That was kind of spot on. It was supposed to hit us today. So we'll bring up the solar wind data and I'll show you. Hold on. Let me make sure I do this right. So you're not seeing a bunch of stuff. Did I really close everything out? Oh my God.
Want me to jump into Helio viewer first?
Sure.
Fill some time that way.
Go in the.
Well, I got some. Well, I do have data
Here-
up to
here we
worst
go, the
case if you
data's
just want
up.
to see
We'll
it
just-
from my screen.
We'll use this since I closed everything. So anyway, you can kind of see towards the end of that
Let's get rid of BY here.
end of the thing, that something arrived today with there was a jump in the BZ and BY. So that's probably the, I think.
Oh no.
Was it the filament? I think that's the filament. Was that the one they were talking about, or is that the one on the 4th? I think this is supposed to be the filament though. But
There we go.
from what I've heard on this, the high-speed stream that was in front of it did a pretty good job deflecting it off to the east, which they tend to do. So it's not like that big of a hit, but it's on time. It's on time from what the forecasters were saying it was going to be. But what I want to point out with this high-speed stream is like it was a high-speed stream. We're starting to get some pretty decent coronal holes now that we're on the declining phase of this cycle, and it hit. There were a couple times it might like a couple of those spikes. It was over 800 kilometers a second. I mean, granted, it wasn't there very long, but the average was like the upper 600s. And
Yeah.
according to some of our favorite heliophysicists, like Tamitha included, she thinks that this cycle is going to be the return of the true high-speed streams, where we start seeing coronal holes that have fast solar wind. And I think she was trying to think back in solar cycle 24. I don't think there was a single coronal hole that got near that.
There was a few 700 kilometers a second
Yeah.
ones I do remember.
So
They were not very long, but I think that's about the highest I saw. 700, maybe 750.
yeah.
There might have been one 800 occasion. I am not 100% on that one though.
It could be a fun little project for the week to see if we can find the
Actually, that's a good point.
highest coronal hole stream of the cycle 24. But anyway, so
Let's
that's kind
see.
of the some of the tidbits I wanted to bring out with this particular event is that we've been under it. There was some decent aurora that came from it. Some people caught it. There was a lot of cloud cover with some areas, but I know people like Patrick was able to get it in Mackinac in between the clouds. So
There's a few good substorms.
yeah, there was a few good substorms that come out of it, but it was positive polarity.
Yes.
If I remember correctly, and as we're coming into our RM effect, was it the spring is we got the negative ones, but we're still kind of early for that. So anyway, I digress. Anyway, so that's kind of the short and long of it of current solar wind data. I was gonna try to find out where the CIR came into here, but I don't even really want to guess.
This is a mess. I wouldn't dare even try to guess myself. It looks like in general the CIR would have been somewhere within this area, And then as V started going towards the away orientation, we got the solar wind speed start jumping up. So this would be the main coronal hole part of it. And the CIR probably kicks in somewhere around here. But again, it was already elevated before that from a glancing below CME. It was
yeah.
hard to tell.
So your guess is as good as mine on that. But you can see
messy data.
You can see pretty clear where the high speed stream kicked in though when that speed.
Oh yeah, we ramped up from 400 average all the way to 600, 650. And that stayed for what, day and a half?
Yeah, quite some time. So it was pretty good.
And now we're starting to tail it back down.
Pretty good. Anyway, so what we got next? You want to bring up HelioViewer since you got your computer up?
Yep, might as well.
Thanks for saving me on that one, since I wasn't prepared.
I just happened to have it up too. Really just looking at the, let's go, we don't need all this stuff here. So current sunspots are kind of what I want to address primarily at the moment.
We have a good one.
Yes, these are, let's move to today as well. Actually, let's just do this. So there's a giant cluster in the northeast region of the sun right now, which as of just a day and a half ago looked like this. And now these are, if we're looking at the magnetograms, which I got to stop resetting by accident so that my polarities aren't missing. There we go. This is also a mess. This looks about as messy as the solar wind data that we were looking at. We've got at least 2 separate regions in here from the looks of it, and then this might be its own little region too, but they're all kind of smushed together, so it's hard to separate one from one. This might even be like a vertical one, or just a very strong unipolar group, but I can't tell anymore. But what I really want to address is this region right here, which over a short 24 hours grew to be quite large.
Look at that.
And in fact, we already have, it's already bigger than most of the ones here, and we have a fairly distinctive deep delta here.
It's pretty gnarly. There's like two.
So
there's 2 of them in there.
Oh, actually, I didn't notice that. There's a channel. Oh, that's pushing into the Umbra. Oh, that's cool.
That's funny because that's the one I saw first. Was that one over there?
Yes, you've got, this is all negative flux being pushed into the positive Umbra here. This is looking promising. If we're going to have any major flare characters, I'm going to say it's going to happen from here or collectively from here, but I'm going to be looking at this region over the next 2 days, I'd say. We should start seeing some R2 and R3 alerts from it, probably Dandy type. No, that's a little bit of a guess, but just based on the fast growth, it's probably going to continue growing and pushing. So that's sunspot regions. There's nothing else really interesting going on in the solar disk outside of that region. This would actually be, for anyone with a solar telescope or even just a solar filter for telescope, this would be a pretty cool region to get for camera. I think Bob King had a photo earlier today from it, and they are pretty photogenic looking. I mean, obviously they won't have the color to them, so you
yeah,
get
to look
something
like that.
this.
But it's still cool. Actually, yeah. Maybe I'll do it
And then,
tomorrow.
as far as eruptions, I don't really see much over the last 2 days. Even looking at 304 in the chromosphere, there's not too much going on. That region's still looking potent. Oh, let's take the track off. The whole northeast region is still looking potent, but there's really not many things going on. Until literally, like, not very long ago at all, there was an eruption, almost center disk here. No real CME coming out of it yet, at least that we can see, because as we go to Glasgow, we already have a couple that are farsighted, unfortunately. So before everyone else starts freaking out about it, or if they haven't looked at it yet, we have one full halo on the backside right there. And then there is one that is beginning to emerge to the southwest over here. This is also farsighted, is the sad truth. We see some connections, some field lines breaking on the south area, which looks like it's coming from the back, and there's no signs of an eruption on the front. So both of these major CMEs are not front-facing. So, sorry, as per usual, I feel like.
But I guess we have to wait a little bit more to see if that long duration one did anything.
Yes, I don't see anything coming from that yet, but it is going to be a little more difficult now that we've got a super bright one, which, why does that always happen? We have to find a faint CME that's heading towards us with a big CME that's bright, not coming towards us. I find that's more consecutive than anything else.
That's all those
but that's just our luck.
Forecasters' nightmares. That's for sure.
I don't envy them. And let's see, that was all I had, I believe. And then just to confirm, the actual coronal hole is passing We have almost the full edge of that now, passing what would be the Sun-Earth line, and within the next 24 hours, we should be back into ambient solar wind, assuming we don't have CME influences still from the side hits.
Correct.
And that's all I've got.
Okay. So now we can go on to the science portion of
The main presentation.
of our show.
Well, one thing I wanted to mention before we go into science is we're going to see those events that are more compound, where it's kernel hole and the CME, and we're going to see CMEs that will be very frustrating because they're going to be deflected by kernel holes. We're in the declining phase of the solar cycle, so it is a mess out there, and it's really different features fighting each other, which is why it's good to go over the solar synoptic maps. All right, let's start this. So, why should you care about solar synoptic maps, and why should you look at them every now and then? Well, first of all, they're kind of cool. They started back in China. 364 BCE was kind of the first whole disk, well, not whole disk, but at least the sunspot drawing. But the person who started the entire thing is probably Galileo Galilei, because over summer of 1613, he had whole disk drawings, consecutive disk drawings, and you could see the migration of solar spots. But those solar maps were not really connected to space weather events. As you imagine, Galileo Galilei lived pretty far from auroral oval, so the whole thing of something happens on sun and it's somehow connected to aurora was really not becoming very apparent. And on top of it, we did not have any technology that was sensitive to space weather. So there was no reason to care about it. And again, this is all more or less just white light observation. So other solar features were not observed, and we would have to wait for more technology to see what sun really looked like and what features it had. But before that, several scientists back in 19th century were observing sun and actually creating synoptic maps, just solar spots, no filaments, again, no way to observe them, no really good way to observe prominences except during solar eclipses, which are not that common as we know it. And back in August and September of 1859, this big spot was observed by at least 3 different, now come to think about it, 4 different astronomers, including Carrington, who recorded it as group 520. Schwabe, who we know as Schwabe cycle, so the 11-year cycle is called Schwabe cycle after this scientist, recorded it, actually split it into 2 groups, 142 and 143, and it flared on September 1st, 1859. We had magnetometers back then, and it created a pretty impressive magnetic crochet, so it essentially ionized the ionosphere, a sort of additional kick to it, that created a magnetometer deflection of 110 nanotesla, which is pretty impressive.
Okay, I've seen over 5 or 6 different magnetic crochets in the last 10, 12 years, and they're all anywhere from 10 to 30 nanotesla.
Yes.
That's the biggest I've ever seen.
So
Usually from like an X8, X10. They're usually pretty impulsive ones too. That's wow.
And that
Yeah,
was
huge.
so
and it was
in
cool.
in modern terms, if you look at auroral electrojet index, 110 nanotesla, you'll definitely see it. It will register. So that's why it was estimated to be the X45 solar flare. And because it was pretty high speed CME that resulted from that flare, it actually created a very widespread auroras. And there was technology that was very sensitive to space weather. That was telegraph. It was really kind of the first long distance line that depended on electricity that was created by humans. That was way before electric grid became a thing. And they did experience geomagnetically induced currents in telegraph lines. It was shocking the operators, and some operators were able to transmit signal without really having power on. It was all just powered by the storm. So that was pretty cool. Again, that was a technology that was more relying on direct current. So even though they had current flowing, it wasn't creating major disruptions. There was nothing to melt there. But they started to pay attention to what was going on. And there is a paper that discusses the observations, and we'll definitely put it in the video in description. It's kind of cool to read it because that same spot probably generated more auroras than we talk about when we discuss Carrington events. So it was definitely very flare productive and very CME productive.
Yeah, what's cool about it was that event. He drew the flares. So because that was like a white light flare, which is rare, and he actually drew it in the maps. So that's kind of another cool little thing that came out of that whole event.
Absolutely. And because he drew that flare, we think we know what part of that spot was a delta spot. At least the sunspot region had a delta magnetic complexity. So why have solar maps in the first place? Well, first of all, again, there's that connection between solar features and geomagnetic storms or disturbances in general. We started to get more observation tools, and we noticed that there are more features there that would be very important to note, mainly filaments and coronal holes that can generate storms without really having a whole lot of flaring with it. And we got magnetograms. So solar maps include the magnetic complexity of the sun. Sun is kind of liquid magnet, and how it evolves over time and over solar cycle is also important to know because you can, to some degree, anticipate how active space weather you're going to get. And again, with communicating between scientists and within operational space weather forecasting world, having a unified system to name active regions and to name coronal holes and know which feature you're actually talking about at what time period became very important. So this is how solar maps and solar synoptic maps essentially started. And this is just one example. This is from May of 2024. And you see our favorite spot there, 3664. Yep, it was magnetically complex. And this is how that complexity reflected in the flaring risk. So 90% for C flares, what is it, 75 for M flares, and 30% for X flares. Again, biggest predictor of future X flares is an X flare that was produced by the region. So we shall see what the new region is capable of doing. Hopefully it will be flare and CME productive, not just all flashing lights and not a whole lot of plasma released.
Because if I do remember correctly, 3664 also developed pretty fast too.
Yeah, a lot of the major flare groups that I've seen over the last couple of years have always been very fast, just fast emergent flux, really complex right off the bat, and then bing, 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 bing.
They scream a bit, and then they go away.
Yeah. Or they last for, I mean, there's a couple in cycle 24 that went through rotation.
Yeah, that's true. They do.
All right. So even though we have, to some degree, a convention on how to name those solar spots, there are different maps. So the numbering started on January 5th of 1972. And this is the first synoptic map that was created by SWIPSI forecaster, and they have been doing it ever since, but this is June 2nd, 1972 map. So those numbers are very, very early numbers, but it literally started with number 1. They have, I think we are way past the 10,000 active regions at this point. And the convention is to just use the last 4 digits for the sunspot, even though they do have a much longer number. It is usually drawn by the forecaster on duty. So the forecaster on duty will be there. That's their name. Or last name, I should say. And it's kind of a good way to get oriented to what sun is up to and where different features are, because you're going to be watching that sun over next shift. And it's good to know where it's flaring and where CME is originating, or which filament is flying and which way. Historical synoptic maps are available, so if you're curious, go into onto SWPC website and check them out. You can see what they look like. If you want to look at your birthday and see what your sun looked like on your birthday, you can definitely do that. And actually, you can do that, and that was way before SDO or any other satellites that are really monitoring sun in real time became available. So this
Assuming you're millennial or less.
That's very true. So before June 2nd, 1972, that's going to be a little bit challenging. There are some synoptic maps that are available, but SWPC really, that's kind of when they started. Should we look at one in real time?
Yeah,
see what's going on. Let's do
Since
it.
we have an already look as to how things looked today.
So this is
today's
current solar synoptic map. This is today's date. This is when the map was created. So that's in universal time coordinates. This is the forecaster. And it actually tells you what Carrington rotation it is. Yep, that's right there. Next number of the region, so people do not forget, and some of the errors are reduced for numbering. Next region, next coronal hole will be listed there. What else do we see? Oh yeah, that's the flare risk.
Flare probabilities.
Right there. And those are, this is what was used for creating the map. So 2 coronal holes right there. This is one, this is the second one, and this is the region that is becoming very, very active. There's a returning coronal hole right here. It's very close to the limb, so it's still looking a lot shorter than it really is. We will see it a lot better in just a few days, and we'll see how it compares to the one that we had 2 weeks ago. But this is what the declining phase is shaping out to be. It's like one coronal hole is leaving, another one is popping up, and we might see that CIR going every 2 weeks or so.
And then notice we have active regions in between them.
We do.
Love that.
Yeah, so it's kind of fun. Well, what is I like to use Scott's term, the battleground, because that's kind of what we're dealing with here, so it makes it interesting.
Yeah, and we are dealing with preferred longitudes. So coronal holes and active regions kind of do have a longitude where they prefer to sit. It changes a little bit because of the drift and differential rotation over time and over solar cycle, but not by much. So they kind of occupy a certain longitude and just stay there. That's why the coronal hole base forecast is really 27 days. They do come back. All right. So that's where we at.
Should we go over some of the thing like coronal holes are denoted by that line with the dashes inward? And then
so all that information of what different coding means could be found in detail. So active regions, coronal holes, neutral lines, plages, filaments, and prominences. So definitely read the details, and it will help you to understand the solar synoptic maps. They're fun.
They are fun. And you can really read then into them as much as you want or as least as you want. You can get a ton of information, or you just get a basic understanding. Okay, there's a lot of groups here, and there's a few kernel holes. Or do you want more info than that? Well, you can dig in for a while.
Yeah, and you can definitely see what the probability of flaring is like for each region. At least that's the case at the time when the map was created. It changes over time. Because regions do evolve over time, and we have seen it with 3981 that it changed over time, so it's probably going to be assigned a higher probability of flaring in the following days.
In fact, it looks like it has the second highest currently probability out of the ones I'm looking at now.
Definitely. Which is not surprising. It increased in complexity quite a bit, so it will be higher for the flare per flare. All right. So that's SWPC. Is it the only one? No. Other agencies make their own maps, and this is where approach to different region can vary just a little bit. So this is a map that is created by Met Office or MUSWAC, And they use known numbers, and instead of putting the flare probability, they give you the magnetic complexity and Zurich-McIntosh classification of the sunspot. But otherwise, it looks very similar. So first of all, it's Stony-Hurst coordinates. You can see the pole, and you can see where sort of the way you look at the sun, it's not just a disk, but you know whether or not you're seeing a pole, so it does include that tilt and your location in relationship to the sun. But you'll see the coronal holes, you'll see the filaments, and it will be designated whatever polarity. So positive polarity here, negative polarity. Numbering is the same. So coronal holes in SWIPSI map will be the same number as coronal hole in the Met Office map. Same goes for active regions. So there is a lot less confusion there, which is convenient.
Yeah, that's nice.
But yeah, whichever you prefer, it doesn't really make a difference which one you're using, whatever you're comfortable with. If you like to know what's going on at the poles, and that's somewhat important later on in the cycle because we can start seeing polar coronal holes opening up. I actually seen one already, but it sort of rotated off. But yeah, that's where that, and Met Office is doing it twice a day on a regular basis. If you want to sign up for their forecasts, you can do that. You just need to create a free account and register for mail. Basically, you do a mail subscription for the forecast. It's pretty useful. You just get one in the mail, you read it, you read about the forecast, you read about what happened, you read about risk of different geomagnetic storm levels. It's very detailed. So if you want a short and to the point, go with SWIPSI forecast. If you really want more details and kind of learn about how you think about events and how you think about what those events mean, that's probably Met Office forecast. They're very
cool.
similar. There may be a slight difference in assigning the risk because they do map their own CMEs and kind of figure out if it's a glancing blow or more direct hit based on that. But overall, in terms of mapping and in terms of description of events, either one will be great. All right, moving on.
Onward.
Onward. And we got one of the European agencies doing this. So again, it's Stony-Hurst coordinates, and because there are different numbering of the system, so SITC has their own, you can definitely pull that on the map too. It gets very, very busy, but if you want to exclude some of them and just strip it down to pretty much just no active regions, you can do that. And then that's what you're going to see. So same numbers, except this time it kind of maps it onto the actual disk. So you don't see a map, you see sun. And what do we have here? 171, if I'm not mistaken, angstrom?
Yes.
Yeah.
Thank you for confirming that. So you'll see what's going on. You start to recognize those regions not just by number, but you know what they're gonna look like when you look at SUVI or SDO, which is also pretty convenient. So, all right.
And then what do we got? Oh yeah, we're onward. We're getting there.
Onward. Yay. We also have we can either go to the original for original source data, or we can look at our app, Space Weather Live. And if you like that, if you already have that app, I highly recommend using it, at least for sunspots. They do a great job. They keep updating it every hour, and that number will migrate with the spot so you know what you're looking. In terms of the flare risk, they are color-coded for magnetic complexity. And I can pull up their website, which is right over here. So it will give you a description of each sunspot. And if you click on that, you can look at it up close and personal. So let's go to the region that has not the highest, but second highest probability of flares, which I think is this one. Yep. Oh, will it load?
It's like, no.
I was gonna say, it looks like they were lagging before.
Yeah, that's
Oh,
the
there
case.
it is.
There we go.
There it goes.
So,
And then you can slide the slider over back and forth between. Yeah, I love that.
Yeah, that's pretty cool.
yep. So depending on that, when that picture was pulled from the source data, you'll see it in probably real time. So that's probably close. I'm not sure if they post anywhere when the picture was last updated. But yeah, you can see there is a delta region right there.
There's
Right there.
pretty good shearing.
Yeah, pretty decent.
Excitement. I like it.
And it gives you the location, it gives you Zurich Macintosh classification and Mount Wilson, which is magnetic complexity, size of it, number of sunspots. It will give you evolution over time, so also very useful to track. And unfortunately, that's probably the only thing you get from that map, because you have to go to different maps to figure out what sun is up to. So coronal holes will be on a different map, and I don't think they map filaments. You can see them still, but it's a bit difficult. So there are several different maps you have to look at in Space Weather Live, as opposed to really just one map when it comes to SWIPC, Met Office, or C.
AIA 304
Still useful.
for anyone interested. That'll be your chromosphere, filament, prominence, and kind of active region channel.
Yeah,
I don't think they do
filaments there.
gong imagery on here though for the H alpha, but H alpha would also be a good one.
Yep.
No, okay.
All right. Moving on. Yeah, we don't have that much left, actually. There are definitely limitations to synoptic maps. They are done once or twice a day. And during that time, a lot of things can change, including some of the rapidly evolving active regions. Sometimes there are observer errors where coronal hole or active regions may not be numbered, or it's assigned a different flaring risk. But ultimately, we're all human. We'll all make mistakes, and this is pretty normal. So it's not a big deal as long as that coronal hole is on the synoptic map. Usually the error is picked up and corrected at a later time. But if you notice that, feel free to send a note to SWIPC. They do appreciate it.
Yes, they will correct it. We have had to
They
do
will
that.
correct it. Yep.
Not
We have
saying
done that.
anything from experience or nothing.
Hey, we're human.
I know.
And there are a lot
Yeah.
of numbers, and it's still a very active sun, so there are a lot of features to keep track of on the sun, so mistakes can happen.
And voila.
All right.
There's our little intro to synoptic maps. I can't say that word. I just can't. So anyway.
So that was fun going off of the coordinates, and then we get to go into synoptic maps, which then have different coordinate systems.
In case you
Just kind of building.
In case you weren't tired
Prior
of
lessons,
systems by
yeah.
now. Anyway, that's our little gist of the day. I don't think we have any questions, but because it's kind of.
I want to do one thing. I guess Janelle had a quick question on. I don't know if it was a J-Helio viewer thing or not, but
if you can invert the
the color, yes. Yeah. If you're actually using, the question was specifically J-Helio viewer, there's an invert button down here.
Oh, yeah.
But it's running differential imagery I'm using, which means you can literally just go back and forth with it. No, you have to turn tracking off, though. That helps. But you can just go back and forth with it, and it will also do the same thing. Because it's adding or subtracting the difference that's there. So, kind of arbitrary.
Yeah.
That's all for that one.
So, let's see. I think that covers it. And as far as, future stuff, well, we have the sunspot to look forward to. So I know it was kind of funny because I watched Tamitha stream yesterday, and because she puts up her forecast for the whole week, and then I remember her saying, "This will probably change," and then today we see this active region just come out of nowhere, basically
popping it from nothing.
So stay tuned because that might actually be interesting to watch. And then we have the one maybe something on the 4th-ish. From whatever eruption that was.
At this point, the
so
eruptions are
professional.
they're so tiny though. Like if we
Yeah.
get some actual decent CME our way, we're not going to be this lax about it. But really, I wouldn't even focus on an eruption coming. It's going to blend in with background. If it were to show up now, it wouldn't even really be anything.
All right. So we'll keep an eye on the sunspot, and if something really cool happens, we'll just do another live feed. How's that? I think that's fun.
I think that's a good deal.
And then in the meantime, what do we want to do next week?
I haven't decided on that yet, or even have an idea. I mean, I have a couple ideas, but
Okay, I know.
we could use comments for ideas, maybe.
I know. We need
What
to.
do you guys want to learn?
Wait. Should
Oh.
we do because I know there's been a few requests, well, magnetometers. I know we've been putting that one off. And
We should just do a general overview of
and
one,
flux ropes. Flux ropes.
just to sort that. What was the second?
Flux ropes.
Oh yeah,
yeah.
Maybe we can do flux ropes next week. Because that kind of
Actually, yes. Now that we've covered active regions and coronal holes, flux ropes would be the next topic.
Ooh, okay, so
This is what active regions do.
I mean, I still have a presentation on the data analysis of it.
Out. The infamous slinky. I can do the slinky.
Yay! Let's do this.
You'll have to, because I don't have one.
It's not going to be nearly as cool as Tamitha's presentation, but I will try my best to bring some humor into it and make it so. So anyway, thanks everybody for watching, and hopefully you got something out of this. And then we'll cover flux ropes next week.
Yep.
Yay! All right. So you all have a good night, and I will end this on the YouTubes. So
Good night, everybody.
Good
Or good
night.
morning, Southern Hemisphere.